Good evening, students. This is video 6.8. Your objectives are, I can dilate a figure and determine its, not if, its scale factor, and I can identify dilation as a similarity transformation. Your Excel skills for tonight are going to be L14 and L15. Glad to see many of you starting those. Lots of emails went out today about Excel skills, so please make sure if you have not gotten them done that you get them done. All right, let's go, flippers. So a dilation is a transformation that preserves angle measure. That's it. That's all it really preserves. And there are two specific types of dilations. The first one we're going to talk about is an enlargement. Okay, so let's start off with our pre-image. So this is our pre-image, and our pre-image over here is going to be called Mugwump. And Mugwump is a cool wump, and his name is Mug. So he's really cool. He's got these really awesome angles here, here and here, even more angles here and here, and here and here. Really, really cool dude. So if I were to look for an enlargement of Mugwump, that would mean that the scale factor is going to be greater than 1. Okay? So scale factor is greater than 1. And the example of that would be over here. Well, let's just call him Chugwump. So Chugwump has a scale factor that is larger than 1. So he is an enlargement of Mug. An enlargement. All right, so the second one I want to talk about is going to be a reduction. Okay, so a reduction would be actually a scale factor that is between 0 and 1. So if I clearly have a reduction like I do here, then the scale factor is going to be, again, greater than 0, but less than 1. So in between those two whole numbers. And here he is. Let's call him Tigwump. Tigwump. Okay? So again, if you look at all three of these, the pre-image, the enlargement here, and the reduction here, you will notice that the angles have been preserved. Very important fact. The scale factor for the reduction here could easily be 1/9. The scale factor for the enlargement here could easily be 3. And again, we can measure those. Okay, let's take a look at our first example, number 1. It says, the green shape is a dilation of the black shape, which means that the green shape is our image and the black is our pre-image. So that means the green is our shape that we have now created. So we're looking to figure out, well, is this an enlargement or is this a reduction? Clearly, the black is bigger, so that means it's gotten smaller. Therefore, this must be you guessed it, a reduction. And it's going to have a scale factor that is, again, greater than 0, but less than 1. So let's now look at question number 2. This one says, is dilation of ABC, A prime, B prime, C prime, D prime, an enlargement or reduction? And here it says, what is the scale factor of the dilation? So we have two things to do. Figuring out if it's an enlargement or reduction and what the scale factor is. Since for this problem, ABCD is marked as our pre-image, we know A prime, B prime, C prime, D prime is our image. So we know this has gotten smaller, so this must be then a reduction. In order to determine the scale factor, we need to focus on a specific point. So let's focus on point A. So it's clear here that point A is located at -8, 4, and A prime is located at -4, 2. Now, since this is a similar figure and angles have been preserved, we can clearly determine the scale. The scale factor is clearly determined by thinking about, well, I have -8 And I just have to ask myself, well, what do I have to multiply negative 8 by to get negative 4? Now, I know you're thinking, well, I could just divide these two. Well, you can't divide because scale factor means multiply. That word means you have to multiply. So here I have to multiply negative 8 by something to give me negative 4. And the only thing that works here would be 1 over 2. And if you go ahead and multiply it out, you get negative 8 over 1, and you get negative 8 over 2, which equals negative 4. So that means the scale factor then is that 1/2, which makes sense because a reduction has to be between 0 and 1, and we are going to get 1/2. Question number 3 says the blue shape is a dilation of the black shape. What is the scale factor of the dilation? So here, this is very clear. Again, we're starting with a larger shape. We're ending up with a smaller one. So that means this is going to be a reduction, and we're looking for the scale factor. Here is the point that I picked to use. I picked C on the original pre-image and C prime here, and I wrote down the points, negative 8, 4, and negative 2, 1. So again, I want to ask myself that question. What do I multiply negative 8 by to get negative 2? Okay, remember, I cannot divide. I have to multiply. So the only thing I can multiply a negative 8 by to get negative 2 is going to be 1 over 4. Okay, and I'm going to end up with negative 2. Bam, it worked out. So the scale factor here is going to be 1/4. The last question is asking us, well, what are the coordinates of the vertices of a dilation of 2 on triangle PZG? So let me graph that first on this bigger grid. Here are our 3 points graphed on the coordinate plane. And here are the points themselves written out. So now we're going to put them under a dilation of 2. Those points have clearly been all multiplied by a scale factor of 2. So now let's graph them. There are 3 points. Let's connect them. And there we have it. Our secret hot question for tonight. It says, is the dilation shown here an enlargement or a reduction? And then it wants to know, well, what's the scale factor? And here are the numbers over here. This length is 4. This length is 8. This is x prime x, r t, r prime t prime. Remember to work on your IXL skills, L14, L15. Go ahead and give yourself an internet high five. Woo! Awesome. See you tomorrow.